Hello and welcome everyone to the How to Be channel. In today's video, we will go through a career in chemical engineering and share our thoughts with you so that you have an idea again about this particular branch of engineering and perhaps you can make your own picture of it. So throughout the upcoming slides, we'll go through a brief introduction, fly over the definitions, then we dive into the school program to go over specializations, duration, courses, diploma, and advanced degrees. Next, we'll speak about jobs and industry fields, including CV, skills, profession regulations, salary and job indicators, common position levels, example of job listings, software and application use, and lateral and vertical move during a person's career. Finally, we'll end up with the career goals and aspiration tips and finish with the dream slide. So deciding on a career path is perhaps one of the biggest decisions you will ever make in your life. This is why it is important to gather as much information as you can to help you choose the right career path and hopefully to enjoy the experience as it is a lifetime decision. Again, as this is repeated in our previous videos, the best way to help you choose or decide on a career path is to ask yourself the right questions. What would you like to become? What is your career dream? What are you interested in? What career or job you believe will make you happy? Are you looking for a routine job or a more evolving and exciting experience? So some questions specific to chemical engineering career could be, are you interested in chemistry? Are you fascinated by oil and gas, electronics, chemical plants, materials, design and testing, solar panels and battery manufacturing industries? Are you appealed by food processing and food industry? Are you interested in working with materials and processes that can achieve great things for society, from food to electronic industries? Uh, well, are you comfortable again working on a computer and doing testing and simulations part of the time? Well, after objectively answering the right questions, it may be easier for you to decide which career path you may be really looking for. Um, So chemical engineering is a branch of engineering that use principles of chemistry, physics, mathematics, biology, and economics to efficiently use, produce, design, transport, and transform energy and materials into useful products. It is a wide-ranging branch of engineering that keep evolving and adding multiple contributions to our worldwide societies. The main activity sectors are manufacturing, medical and pharmaceutical, healthcare, petrochemicals, electronics and materials, biotechnology, etc. Also, in general, the main industries of employment could be chemical industry, petrochemicals, food engineering, chemical plant, environmental engineering, medical and pharmaceutical, material science, etc. So one important note on the school program is that most engineering programs, again, similar to our previous videos, are provided by universities around the world. Requirements for program registration are usually listed in each university webpage. Details for the program and list of choices provided by the university are also commonly available. And it is important to note that some engineering programs require minimum pre-university grades or scores for entry, which is also listed in most universities' websites. So chemical engineering has numerous sub-branches, also called specializations or sub-branches. Specialization mean you will get a more focused education in a specific field. And it is important to choose the one you like, as these specializations will often open doors to specific fields of chemical engineering. Uh, from web research, we can cite some specializations that are listed, and these include material processing, material synthesis, environmental engineering, alternative energies, biomedical chemical engineering, food engineering, engineering design, pharmaceuticals, healthcare, petrochemicals, electronic and advanced materials, polymers, biotechnology, design and construction, microelectronics, etc. So some things worth noting here, again, are that similar to other engineering programs, most universities do provide bachelor engineering degree in 4 years full time, including internships. Master's, which is the next degree, also called second degree in engineering, can be obtained following 2 additional years of studies. PhD, which is the next step, also called Doctor of Philosophy, uh, or third degree in engineering, can be obtained following 3 to 6 additional years of studies, often depending on the student invested time, subject, field, university, and other factors as well. So in summary, chemical engineering or bachelor degree is 4 years, master's is 2 additional years and is optional, and finally PhD is additional 3 to 6 years, which is again optional as well. So in this slide, we see a list of common courses, example here again from McGill University, that are to be completed at university for a bachelor degree in chemical engineering. These courses do vary a little bit from one university to another, but the main programs in general are similar. So some courses may be more important to you again. For example, aiming for a career in food processing, you will have to work very hard in most courses, but you may be specifically interested in courses like organic chemistry, food process engineering, process design, process modeling, instrumentation and measurements, etc. Also, as you can see from example here, there are multiple aspects of chemical engineering that are reflected in this list, and it is important to have an understanding of the learning materials, especially as a chemical engineer may often be called to work in different industries throughout his career. So some thoughts about some of the courses that are commonly used by chemical engineers could be: one, chemical engineering principles. Well, chemical engineering have gained substantial knowledge, and the foundation of it are the principles which every chemical engineer is invited to learn. Second, instrumentation and measurement, which is the foundation to get data and control processes. Understanding the instrumentation used in this field and the measurement techniques is crucial as well. Third, chemical processing, electronic industry. While the electronic industry is booming and many processes use chemical engineering principles, technological advances would not be possible without knowledge on these chemical processes. And the combination of electronic industry and chemical engineering principles have opened doors and made many innovation in our society as well. Four, material science, which is an important course to gain understanding on materials used in chemical engineering and also their properties and behavior under different conditions as well. Five, physical chemistry for engineers, which is important to understand the microscopic and particulate phenomena in chemical systems like motion, energy, thermodynamics, etc. Six, materials engineering. Well, design of new materials have been the push to make many achievements in many fields and industries. New materials development is known to open doors to many advances in science and technology throughout history. Seven, chemical reaction engineering. Well, understanding the basics behind chemical reaction is crucial to understand the different transformation from one chemical substance to another, and is equally important to understand as well for chemical engineers. Eight, process design. Well, design principles of chemical processes is again the foundation for processes development and is important for most chemical engineers as well. Nine, process modeling, which do provide the teaching on the techniques that are used to be able to predict the chemical processes results. Example here is results of a chemical reaction. So understanding the principles is key as well. Um, 10, polymers, science and engineering. Well, polymers, example given here or by definition is plastics, are used everywhere, from the ground to our kitchen, cars, electronics, etc. The field of polymers and petrochemicals have been consistently pushing technology above and beyond. 11, polymers processing. We can say that pushing polymer use and utility further will keep opening doors to future technological advances. So understanding the processing of these materials is important as well. And 12, food process engineering, perhaps noting here that food processing is the transformation of agricultural product into food. Example given here include flour, dairy products, etc. And understanding the engineering behind is important part of the learning. So it is important to note again that all courses provided are important, and for a student the best path is to try to excel in all of them. It will only be rewarding during that person's career. Now, what diploma will you get? So let's start to see what is a diploma. Again, basically a diploma is an award given to you following completion of a school program. A copy of each diploma is normally requested by the employers during job interview process. So it is particularly important to preserve these documents throughout your career. For a chemical engineering path, these diploma are listed as follow. Some of them are optional again. So for bachelor degree in chemical engineering, the diploma is bachelor degree in engineering diploma. For master's, the diploma is master's degree diploma. And for PhD degree, the diploma is Doctor of Philosophy diploma. Note that master's and PhD are optional only for those interested to go advanced, like doing advanced research on a specific subject or field or aspect of chemical engineering. So we noted master's and PhD. These degrees are what we call higher degrees. And again, these are optional, perhaps only for those that would like to specialize more and do research in a certain field. So similar to many other engineering programs, following bachelor degree, a master's degree may be pursued. Most universities do provide two options for masters, either course-based masters or research-based masters. Both do require, in general, 2 years of studies or research based on the master's type, and the diploma is granted following completion of the program followed. So following master's degree, a PhD degree under supervision of an advisor or director may also be pursued. A PhD degree in engineering is mostly research-based, and a certain number of courses must be completed depending on the university program. A PhD diploma is again granted following successful defense of the thesis. So just as a resume, the normal path is bachelor, then master's, which is either course-based or research-based, and finally PhD degree, which these last two are both optional. So one last thing to mention is that some universities do provide the option of moving directly to PhD program following completion of the bachelor degree program, meaning that you can skip masters. However, most of these universities do require a certain minimum grade or score achieved at the end of the bachelor degree. So bachelor degree in chemical engineering opens doors to multiple choices of jobs from multiple industries around the world. So some industries are more developed in certain locations, and it is important to look what jobs are available depending on the living location. However, it's worth noting here that some jobs or positions are not location specific, and you may have to be called to work on projects traveling from one country to another. Uh, Note that job search engines, again, example given here is Indeed.com, or professional networking website like LinkedIn, can be used to assess the availability of positions and industry fields that are operating in a specific living area or nearby your location. So example of industries recruiting chemical engineers include chemical, fuel cells, petrochemicals, medical and pharmaceutical, consumer products, pulp and paper, polymer and petrochemicals, semiconductors, materials, nanotechnology, food and beverage, etc. So following completion of an engineering program, the next major step is to enter industry and get the dream job basically. So one important factor is the curriculum vitae, also called CV or resume, which make a resume of your educational and professional profile. The main sections again of a CV could be name, address, phone, and email in the header of the file, written and spoken languages, education, academic projects, scholarships and awards, computer and technical skills, professional experience, of expertise, hobbies, and personal interests, and finally references which are provided following requests by the employers. So again, similar to our previous videos, worth noting here, CV or resume do send a strong message to the employer about your personal education, career, qualifications, skills, achievements, and interests. So it is particularly important to take the time to draft it and adapt it as much as possible to the job description, as most of the time you will get only one interview, meaning that it is important to prepare for it. Now, skills. Again, a skill is a learned ability to perform a task. Often when employers list a job, they add the job description and the main tasks are listed as well, which means we can ask directly the question, will I be comfortable completing these tasks? Do I have these skills? This is why it is important during the course of the career path of a person is to develop as many skills as needed to achieve personal goals and open as much doors as possible. So on a note here, it is important that knowing the career path and perhaps the dream job early may help in getting prepared to acquire the right skills needed for that job. Common required skills are listed uh, in the web for chemical engineers are interest in chemistry, analytical, interpersonal, logical thinking, work under pressure, creativity, adaptability, problem solving, project management, etc. Other more technical skills could be computer skills, math, attention to details, data analytics, science, commercial awareness, etc. Now, regulations. In general, engineering branches, including chemical engineering, are regulated in most places under various jurisdictions. It means that the profession is legally defined and protected by law in most jurisdictions. One of the main goals of these regulations is, again, to protect the safety and interests of the general public. And keynotes to take away here are that in most jurisdictions, practicing engineering requires permit. Engineering is regulated by law, and chemical engineering is also under scope of these regulations. Example given here, some fields of chemical engineering such as fuel and cell industry. Um, and lastly, engineering certification is obtained following meeting specific requirements that include one, graduation, second, complete examination, and third, accumulate experience. And it is important to know and how to consult these regulations depending on the living location. So for some of you, you may ask, how is it a career in chemical engineering? Well, this slide was prepared subjectively to try as much as possible to give you an idea how is it. Note that in this slide, the higher ranking is the better. So in summary, base salary indicator in comparison to GDP per capita is usually high, meaning salary in general is considered high. Salary increase per experience could range from medium to high, depending on the position itself. Salary promotion per year range from medium to high. Salary range in general could be from medium to very high. Job opportunities is perceived as medium to high. Sector diversity is high. Management opportunities could range from low to medium, depending on the CV, individual performance, and also sector of activity. And startup opportunities is usually seen as medium. Corporation opportunities is high. Research and development opportunities range from medium to high. Lateral move opportunities could range from, again, medium to high based on the local market and economy. And vertical move opportunities usually range is seen as medium. And with this, the overall sense of enjoyment would be, in this case, high. Again, here are other indicators. Please note that in this slide, the lower ranking is the better. So in summary, stress level is usually perceived as medium to high. Competition or number of applications per job listing is ranked from low to high based on the position itself again. Requested experience level could range from low to high depending on the position as well. Job complexity range from medium to high. And finally, working hours usually range from medium to high as well. Now, once in the industry, often people ask, what are the common position levels? Well, for a chemical engineering path, usually we start with junior chemical engineer, then gain the title of chemical engineer after 1 to 2 years of experience. After this, there is a senior level following 2 to 5 additional years of experience, then principal, and finally senior principal, in some cases after 2 to 5 years of experience, which could also depend on the individual performance and as well corporation promotion policy. So example of chemical engineering job listings taken from Indeed.com could be chemical engineer, process engineer, research and development engineer, petrochemical engineer, bioprocess engineer, materials and process engineer, polymer engineer, microfabrication process engineer, pharmaceutical process engineer, process development engineer, battery engineer, environmental engineer, and manufacturing engineer, and others as well. Note that common listings depend often on the living location and industries that are operating nearby your location. So example of software and applications used by chemical engineers include Microsoft Office as an office software. For process simulation and design, there are Aspen HYSYS, Unisim, ChemCAD, BioSteam, etc. For product lifecycle management, there are Windchill, WinCam, Agile, etc. Asana and MS Project are also commonly used for project management, among other choices as well. For mathematical modeling, you have Excel, MATLAB, Simulink, etc. For computational fluid dynamics, some software used include Autodesk CFD, ANSYS, Fluent, COMSOL, etc. For statistical, there are analyses, there are R, SPSS, Stata, and others as well. So all these, among other softwares, are used by chemical engineer during a day-to-day life or work. Uh, Note again that most software, as repeated in our previous videos, these software do vary from one corporation or organization to another, and software is normally selected based on the requirements, intended use, and other factors as well. Now, lateral versus vertical move. What is it again? Basically, a lateral move is when an engineer moves from one position to another while remaining in the same position level, versus vertical move is when an engineer moves from one position level, example given like chemical engineer, to a higher position level, such as manager in engineering. Potential advantages of lateral move could be opportunity for salary upgrade, exploring new teams, exploring different roles and responsibilities, broadening the experience and skills, and the possibility of working in different fields. Um, while potential advantages of vertical move could be higher salary, less technical, more management, higher bonuses, and possibility as well of managing work or projects within a corporation. So in summary, some career goals and aspiration tips are as follow. To achieve a career goal, it is recommended to establish a solid plan and work toward that goal. Organize yourself and know your skills. Keep it professional, and you will gain respect. Organize yourself. Take the time to learn one in new position. Respect of colleagues, humbleness, and patience will always be rewarding. Becoming a good engineer requires time, dedication, and perseverance. Um, Learn how to manage personal time. In challenging situations, talk to your managers. Be honest. Know your role and responsibilities. Explore and have understanding of the standards. Learn the state of the art. And finally, know the regulations. And with this, finally to end with a dream slide, well, would you like to shape the future of materials and chemical processes, design future innovative materials, batteries, solar and energy systems, or advanced petrochemicals, food or electronics and semiconductor technologies? Then chemical engineering is an option for you. Let's start by saying it's not this university or that university that make me a good engineer, but the ball resides on my own hand. So let's work hard to become one of the best engineers. You don't need a good memory or to memorize everything. Technology is here to help and remind you everything. Chemical engineering provide the opportunity to work in advanced and large-scale projects that contribute to our society and also help significantly advance technologies in multiple industries. If you would like to be part of these achievements, then chemical engineering will provide this possibility to you. Finally, work hard and you will excel at your position. The quality of life, the feeling of achievement, the feeling of contribution will come naturally, and hopefully you will achieve your personal goals. And with this, we would like to thank you for watching and hope to have you soon in our next video. And if you're interested by any specific career path, please let us know. So here are the references, and if you enjoyed this video, please hit the subscribe button, follow us on YouTube for new content, and share with family and friends. Thank you.